Now we can do the exercise. First exercise. First question, solve the following linear programming problems graphically. Maximize 3x plus 2y subject to x plus 2y less than or equal to 10, 3x plus y less than or equal to 50 and xy greater than or equal to 0. So we have to draw graph subject to this is that one is the objective function. These inequalities graph you have to draw. Okay. So for that you have to find the points. X plus 2y is equal to 10. So for drawing you have to take equal. Now draw the table xy. When x is 0, 2y is 10. So y is equal to 5. And y is 0, x is 10. The next one is 3x plus y is 15. xy. When x is 0, y is 15. Okay. Then when y is 0, x is 5. So these are the points. Now xy greater than or equal to 0 means x axis and y axis greater than or equal to means right hand side, that is the first quadrant, and z is equal to 3x plus 2y. So we have to draw the graph first. And mark the points. X. We have 10 0, 10 0, 0 15, 1 2 3. Okay. 1 2 3 4 5 6. Here we have to extend up to 15. Okay. So the line you have to extend. 12, 13, 14, 15. So which are the points? 0, 15 and 5, 0. That is one line. 0, 15 and 5, 0. That 15 you have to. Okay, that's 15 is it is 15. Now the next line 0, 5. 5, 0 and 0, 15. The other line is 10, 0 and 0, 5. 10, 0 and 0, 5. Okay. So, corner point, value of Z. What is Z? 3x plus 2y. That is the objective function. we have to substitute x and y in z. So before that, find the corner points where we shade, and the equations are x plus 2y, here I write x plus 2y less than or equal to 10, and the second one is 3x plus y less than or equal to 15. Okay. So for the first one, when we substitute x 0, y 0, 0 less than or equal to 10. That is correct. So towards origin you have to shade. The second one also, when x is 0, y 0, 0 less than or equal to 15. That is correct. So towards origin, that is the region. So towards origin you have to shade. Okay. Now write the corner points. Which are the corner points? Here you have to take 5 0, this point 0 0 also you can take. Okay. 5 0, I will mark here 5 0. When we substitute 0 and 0, you will get 0 itself. Here 0 5, and what about this point? It is 4 3. So substitute 5 0, 0 5 and 4 3. Then origin means you will get 0. 5 0 substitute here, 15, 0 5 10. Then x is 4 and y is 3. 3 into 4 is 12. 12 plus 6 18. Okay. What is the question? Maximize z. So what is the maximum value of z? 18. Okay. Maximum value of z is equal to, maximum value of z is 18. At which point? 4 and 3. So x is equal to 4 and y is equal to 3. Okay. In this way you can solve. Graphical method of finding maximum and minimum value of a function. Okay. Now the second question. Maximize z is equal to x plus y, subject to x plus y less than or equal to -1, minus x plus y less than or equal to 0, and xy greater than or equal to 0. So first constraint, x minus y equal to -1. When x is 0, minus y is -1 or y is 1. When y is equal to 0, x is -1. Okay. Now the next one, that is minus x plus y is equal to 0. xy. When x is 0, y is also 0. This is y equal to x. It is a straight line passing through the origin. So when x is 1, so y is also 1. Minus 1 plus 1 is equal to 0. So here itself I am drawing the line. Okay. Y minus 1 is here. Okay. One, two, three, 4, 5. Then minus 1. Okay, 0, 1, minus 1, 0. 0, 1 is here, minus 1 is here. Then draw the line. So draw a straight line through these 2 points. Okay. Now the second line 0 0 1 1, 0 0 here 1 1 1 1. Then the second line through these points. Okay. A line like this. Now we shade. First one is x minus y less than or equal to minus 1. That is this line, x minus y less than or equal to minus 1. So the second line minus x plus y less than or equal to 0. So for this first one, when we give origin 0 minus 0 less than or equal to minus 1. That is 0 less than or equal to minus 1. Is the statement correct? No, minus 1, 0 is not less than minus 1. So 0 is, for this line 0 is here downward. Since the statement is wrong, you have to draw, you have to shade the upper region. Okay. So upper region means this is the region, visible region for the first line. Now what about the second line? Minus x plus y is equal to 0. It passes through the origin. So we can't substitute 0 0. You can take any other point. You can take, this is a line, it divides the plane into two half planes. You can take either point from the side or from the upper side. So if I take this point 1 0, okay, substitute 1 0 here in the second equation. So minus 1 plus 0 less than or equal to 0. That is minus 1 less than or equal to 0. Correct? Yes, minus 1 is smaller than 0. And minus 1, the point, which point I took? This point 1 0. So 1 0 is this side of this particular line. And that statement is correct. So we have to shade towards that point. That means where we have to shade towards this point. Okay. So is there any common region? No common region. That means there is no solution or no maximum value and no minimum value for this function. No solution actually. The common region is not there. One is towards this side, the other one is this side. Okay. So you can write no maximum, no minimum value for this function. Now the third one, minimize z is equal to minus 3x plus 4y subject to x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, x, y greater than or equal to 0. Minimize, here it is minimize, minimum value we have to find. So take the first constraint, x plus 2y is equal to 8, then xy, when x is 0, y is 4, when y is 0, x is 8. Okay. Now the next line, 3x plus 2y is equal to 12, xy, when x is 0, y is 6, when y is 0, x is 4. Now we can draw. So 0, 6, 0, 4, 8, 0. X. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. and we can mark the points. The first line, that is x plus 2y less than or equal to 8. So 8, 0 and 0, 4, that you can mark. 8, 0 here, 0, 4. So draw the line 8, 0 and 0, 4. Okay. So this line is x plus 2y less than or equal to 8. And look children, here less than or equal, if simply only less than, then we draw dotted line or broken line. Now the next line is 3x plus 2y, that is 3x plus 2y less than or equal to 12. So the points are 4, 0, 4, 0 and 0, 6, 4, 0 and 0, 6, 4, 0 and 0, 6. Okay. This is the line 3x plus 2y less than or equal to 12. Okay, now we have to shade. So for shading, give the origin 0 plus 0 less than or equal to 8. That's correct. So towards the origin we have to shade for this line. And the second line also, when we give x 0, y 0, 0 less than or equal to 12, that's correct. So we can shade towards the origin. So this is the feasible region. Okay. Now after getting feasible region, you have to draw the table, corner point and value of z. Value of z. Corner points. Which are the corner points? One is the origin, the other one 4, 0, 0, 4, and here what is that point? 2, 3. So it is 4, 0, 0, 4 and which one? 2, 3. Then origin is there 0, 0. Substitute all these in z. What is z? Z minimum value. Minimize z is equal to minus 3x plus 7y. Isn't it? Minus 3x plus 4y. Okay, substitute in x and y. So when x is 4, this becomes minus 12. Then here 16, 2, 3, minus 6 plus 12. That is 6. Then 0, 0 means 0. So which is the minimum value? Minimum value is minus 12. Okay. Minimum is minus 12 at 4, 0. Minimum value of z is equal to minus 12 and x is equal to 4, y is equal to